All right, so today we're going to take a look at section 5.6. 5.6 is basically solving equations with absolute value. So we've solved equations before, and this is very similar, except now we're going to be doing it when the equation has an absolute value symbol in it. Okay, just as a review, remember when you see the two vertical bars around an expression, that means that it's absolute value. Okay? And basically, absolute value measures the distance from zero. Okay? Since absolute value is a distance, the answer is always positive. Okay? If you calculate the absolute value of any number, it always comes out positive, or it could come out to zero, okay, if you found the absolute value of zero. Okay, if you have an equation that has an absolute value symbol in it, then that's called an absolute value equation. And let's take a look at a picture, okay, and see how many answers this type of equation could have. Okay, first let's just graph absolute value. Okay, so here's our, you know what, let me get a better window on that. Let's do zoom 6. Okay, there's our basic absolute value equation. Okay, it looks like a V shape. Okay, so my question is, if I put a horizontal line anywhere in that screen, how many times would it intersect the V shape? Well, if you look at that, you might say it depends. Okay, if you put the horizontal line, let's say at 5, well, it intersects that V shape twice. You take and put a horizontal line, let's use a color other than black, right on the x-axis. It just intersects the V shape one time, okay, right at the point of it. And then if I take and put a horizontal line, let's put it at, say, -3. Now you can see that that green line never hits the V shape at all. So depending on how many times that horizontal line hits the V shape, that tells us how many answers there are to an absolute value equation. So our three possibilities when we're solving an absolute value equation: we get no answer to it, we get exactly one answer, or we get exactly two answers. Okay, so those are the three different possibilities that could happen. Okay, so we're going to go through the steps on how you solve an absolute value equation. First thing you have to do is ensure when you're solving an absolute value equation that the absolute value expression is by itself on one side of the equal sign. Okay, what do I mean by that? Well, let's say you had something like this. There's a problem where the absolute value expression is by itself on one side of the equal sign. You have an expression with two vertical bars, and you have nothing else outside those bars on the left-hand side. Everything is contained inside the bars. Now let's say I did this. Now we don't have the absolute value expression by itself. There is something else besides what's inside the bars on the same side. Okay? In this case, we have a +3. Okay? You can also have something like this. Again, this is another case where the absolute value expression is not by itself, because now it's 2 times the absolute value expression equals 4. All right? We'd have to get rid of this 2, and now the absolute value expression is by itself. Okay, we'll talk about what we have to do using arithmetic. It's either going to be adding, subtracting, multiplying, or dividing. Okay, so here's an example. It says, if there is a number attached to the absolute value, okay, so a number right next to it, attached right to it, no plus or minus sign between the number and the absolute value, then we need to divide both sides of the absolute value by that number. So in this case, divide by 3, divide by 3. 3 divided by 3 cancels out. We get a 1. And we're left with the absolute value of 2x plus 5. And then 6 divided by 3 equals 2. Now we've isolated the absolute value expression. Okay, this isn't the answer to the equation, but we now have the absolute value equation set up in a way that we can solve it. With that 3 in front of the absolute value like we had, it's not ready to be solved yet. Okay? Right, so let's say we had two things. We have a number attached to the absolute value, and we have another number added or subtracted. Okay? Well, we're going to do the opposite of that number to cancel it out. Okay? And I'll show you what I mean. Let's look at this example. Okay, this equation is very similar to solving this equation. Both equations basically say 6 times something minus 14 equals 10. Whether that something is an absolute value expression or just a single letter by itself. The steps are the same to get that value. Okay. In each equation, the steps are the same to get that or to get that by itself. Okay. And remember, we follow our SAM method. So SAM, when we're solving an equation, means we do any simplifying using distributive property or combining like terms. We're not going to have to do that here. But then we go to the A, which is adding and subtracting. Okay, in this case, there is something we can add to both sides. Right, so negative 14 plus 14 cancels out. And 10 plus 14 gives me 24. So now I've got rid of the negative 14 by doing the opposite operation of negative 14, which is plus 14. Okay, now my last step to get this ready to be split apart and solved into two different equations is to divide each side by 6. 6 divided by 6 cancels, and we're left with absolute value of a minus 7 on the left, and 24 divided by 6 is 4. Okay, now we are ready to solve. Okay, the next step is we've got to get rid of those absolute value bars. Okay, and we do that by splitting the original problem into two separate problems. And I'm going to show you what we do for how to get each problem. Okay, the first problem we're going to solve, we take the original equation and we just copy it down and remove the bars. Okay, so for the first problem, take your expression you have, which looks like this, and to split it into two, we're going to take that problem, rewrite it, and just take away the bars. So we'd have a minus 7 equals 4. Let me show you what that would look like. Okay, that's one part. Okay, the next part. For the second equation, we're going to write down exactly the same equation that we just had. We're going to remove the bars again, but one more step. We're going to change the sign of the number on the other side. Okay, that's what negate means, change the sign of. All right, so we're going to copy down the same equation again, take away the bars, except change the sign of the number on the other side. So then we have this. Same equation, except change the sign of the number on the other side. Okay. And now we've got one last step. Scroll back down, which is that in between the two answers, you need to put the word or. So we're going to solve the equation on the left. We'd get an answer. In this case, plus 7 on each side. A equals 11. Or, now solve this equation by plus 7 on each side. A equals 3. Okay, those are the two answers to that problem. All right, so we'll go through a couple more and make sure we can do those steps. Okay, let's look at this one. So the first question you want to ask yourself, is this one ready to be split into two equations? The answer is yes. Okay, the absolute value expression is already by itself, so we're going to start by splitting it apart. One equation is the same as the original, just removing the bars. The second equation, same as the original, except we remove the bars and change the sign of the number on the other side. And don't forget the word you put between them, or. Solve this by adding 1 to each side. You get x equals 4. Or solve this equation by adding 1 to both sides. Negative 3 plus 1 is negative 2. Okay, let's check those answers and see if they work. If you plug in 4 for x in the original equation, you get 4 minus 1 is 3. And then the absolute value of 3 is 3. Okay, so that answer works fine. Let's check negative 2. Negative 2 minus 1 is negative 3. Then take the absolute value of negative 3, you get positive 3. Okay, so that answer also works. So that's our first example. Let's look at example 1b. Absolute value of 2x plus 4 equals negative 8. Okay, first question you want to ask yourself, is this one ready to split? The answer is yes, because the absolute value is already by itself and there's nothing on the outside of it. So we're going to split it. One equation is the same as the original, except we get rid of the bars. Next equation, same as the original, except we get rid of the bars. And we change the sign of the number on the other side. Notice this time it was already negative, so we made it a positive. And put the word or between them. Okay, we'll solve the equation on the left by first subtracting 4 from each side. Plus 4 minus 4 cancels out. And negative 8 minus 4 is negative 12. And then we'll divide each side by 2. 2 divided by 2 cancels out. We get x equals negative 6. Or, now we do the same steps to solve the equation on the right. We're going to subtract 4 from both sides and then divide by 2. Plus 4 minus 4 cancels out. We're left with 2x on the left. And 8 minus 4 gives me 4. And I'll finish up by dividing by 2 and dividing by 2. And 4 divided by 2 gives me 2. Okay, let's check those answers. See if they work. Okay, let's start with negative 6. If we plug in negative 6, okay, I'll do it off to the side. 2 times negative 6 plus 4. Checking it. 2 times negative 6 is negative 12. And negative 12 plus 4 gives me negative 8. And now the question is, does the absolute value of negative 8 equal negative 8? No. We said earlier that whenever you take the absolute value, the answer always comes out positive. So what that means is that answer didn't work. When we plugged it back in, it didn't check. Okay, let's try 2. Let's check 2. All right, so I'm going to plug in 2 just like we did before. So the absolute value of 2 times 2 plus 4. Again, checking if that equals negative 8. So we get 2 times 2 is 4. Now let's do it in one step. 2 times 2 is 4. Plus 4 gives me absolute value of 8. And I have a little bit different problem than last time. This time it says, does the absolute value of 8 equal negative 8? Well, no. Absolute value of 8 is 8. Remember, absolute value always comes out positive. So in this case, we get another answer that doesn't work. So what went wrong here? Well, go back and look at the very original problem. The key is that number on the right-hand side. We have an absolute value expression equal to negative 8. Let me show you what that would look like as a graph. Okay, let's get rid of all these. And let's type in absolute value of 2x plus 4. And let's put negative 8 on another line. Okay, we're looking for where these two graphs cross. That's the solution. Okay, so there's our absolute value. There's negative 8. Where does that V-shaped and horizontal line cross? The answer is they don't. They don't. It's not possible to ever take the absolute value of something on the left and have it come out to a negative number on the right. That's not possible. Okay? So what we had here was a problem with no solution. And let me write down how you know if it's no solution. So if the absolute value expression is by itself and the number on the other side of the equation is negative, there is no solution. Okay, so if the absolute value expression is by itself and the number on the other side of the equation is negative, then there is no solution. Okay, so it's very important that you isolate that absolute value expression first. Because let's say you had a problem like this. Absolute value of 2x plus 3. Let's do minus 5 equals negative 2. Okay, well you might say right away, oh, wait a minute, you just said the number on the other side can't be negative. Well, I said that, but I also said that the absolute value expression is by itself. In this case, it's not by itself. The first thing I have to do is deal with that minus 5. So by doing plus 5 on each side, negative 5 plus 5 would cancel. Still have the absolute value of 2x plus 3 on the left, but look at what I have on the right. Negative 2 plus 5 is now positive 3. This is a problem we can solve. Okay, so it's very important you isolate the absolute value first, and then go from there. Okay, let's look at a problem like this one. Okay, this time the absolute value expression isn't by itself. So the first thing we have to do is deal with this negative 2 times the absolute value. So what we'll do is to undo multiplying by negative 2, we'll divide by negative 2. So the negative 2's cancel. We get 3y plus 5 equals, look what happens here. Negative divided by negative is a positive. Now it's a problem we can solve. Okay, the absolute value is equal to a positive number. Split it apart, just like we did before. 3y plus 5 equals 2, or 3y plus 5 equals negative 2. We'll start by subtracting 5 from each side. So we get 3y equals 2 minus 5 is negative 3. Divide by 3, divide by 3. And in this case, we're going to get y equals negative 3 divided by 3 is negative 1. So let's write our answers over here. We're just running out of a little space. Y equals negative 1, or do the same thing here. Subtract 5 from both sides. Negative 2 minus 5 is negative 7. Divide by 3, divide by 3. We get y equals negative 7/3. Don't worry about reducing that because 7 divided by 3, 3 doesn't go in evenly. And we don't need to write the decimal. Okay, so those are our two answers. All right, let's check example 2b. Okay, this one has multiple steps in it that we have to do before we can split it apart. First, we got to get rid of the 8, then we have to get rid of the 5. So first thing we'll do is subtract 8 on both sides. Why? Because we have a positive 8 in the front, and we undo positive 8 with minus 8. So now we have 5 times the absolute value of 6 minus 2y equals 60. Now we've got to get rid of that 5. So we'll divide by 5 and divide by 5. So the 5's are going to cancel. We get absolute value of 6 minus 2y equals 60 divided by 5 is 12. Now we're ready to split it. Okay, so let's split that apart. 6 minus 2y equals 12, or 6 minus 2y equals negative 12. Subtract 6 from both sides. That gives me negative 2y equals 6. And my last step, divide each side by negative 2. Okay, so we get y equals 6 divided by negative 2, which is negative 3. Or, now we'll solve our other equation. Minus 6 from each side. We get negative 2y equals negative 18. Negative 12 minus 6 is negative 18. And then divide by negative 2. Divide by negative 2. So we get negative 18 divided by negative 2. Okay, negative divided by negative, that's a positive. And 18 divided by 2 is 9. Okay, now we can check that answer. Let's just check the 9, make sure it works, back in the original problem. If we do 2 times 9, we get 18. And then if we do 6 minus 18, we get negative 12. But the absolute value of that becomes positive 12. Remember, that's what those vertical bars mean. Multiply that by the 5 on the outside. And lastly, add the 8. We get 68 on the left. And look at what we had on the right to start with, 68. So if you plug 9 in, it does work. And if you check negative 3, that should work as well. Okay, let's look at our last problem. Negative 6 minus 3 times 4x minus 2, 4x minus 2 is an absolute value, equals 8. Okay, first step I'm going to do is I'm going to add 6 to both sides. Okay, always get rid of the number that's farthest away from the absolute value first. Save the number that's right up against the vertical bar for the very end. So negative 6 plus 6 would cancel. We get negative 3 times the absolute value of 4x minus 2. And 8 plus 6 gives me 14. Okay, now I look at it, ask myself, am I ready to split it apart? Nope, not yet. I got one more number I got to deal with on the outside of the absolute value. To get rid of that negative 3 that's multiplied by the absolute value, I'm going to divide by negative 3. Negative 3 divided by negative 3. The 3's cancel, and the negatives cancel. So we have absolute value of 4x minus 2 equals negative 14 thirds. And whether you put the negative in the top of a fraction or the bottom of a fraction, that doesn't matter. Okay, so now next question would be, are we ready to split it? And you might say yes. The absolute value expression is by itself. Okay, while that is true, look at the number on the other side of the equation. You have absolute value equal to negative 14 thirds. Okay, ask yourself, can the absolute value ever equal a negative number? No. This is that example again where the V shape, if you drew it, and the horizontal line would never cross. So there's no solution. Okay, if you go through like we did on example 1b, you can go through and solve it. And you'll get these two numbers, but it's a waste of time. They won't work. Okay, so we don't even have to go through all that work again just to show that there's no solution. Good, so that's how you solve absolute value equations. Tomorrow we'll take a look at how we solve absolute value inequalities. Okay, and your homework tonight is going to be a worksheet on section 5.1. Okay, so I'll put that up so you can start that, and it'll also be in the video online.